So what I want to do first, before we start the next section, we're going to find the derivative of x to the n power, where we just assume n is some positive integer. Okay. So that's our f of x. And we're going to use the limit definition to do this. So we want to find the limit as h approaches 0 of f of x plus h minus f of x all over h. F of x plus h is x plus h to the n minus x to the n. All over h. Now at first we have a bit of a problem because since we don't know what n is, it's like how do we just FOIL it out? But let's I'm gonna just jot down, here's Pascal's triangle. Right? We know that if I were finding, x plus h cubed, I use the row that begins 1, 3. If I'm finding x plus h to the 4th, I use the row that begins 1, 4. So I know that like somewhere down here there's a row that begins 1, n. Right? And that's the row that I'm going to use here to expand it. So I'm just going to do that. I know exactly what to write down. X plus h to the n is x to the n, 1 x to the n, plus n, x to the n minus 1 times h, plus some other stuff. That's all I need to know. Like, there's some other plus h to the n. I know the last one too, right? Okay. And then I'm subtracting x to the n. Now, all that other stuff, like, so we start out with all x's, right? No h's. And then we bring in an h, and then all the other terms have more factors of h, right? I've got an x to the n minus 2h squared. I've got an x to the n minus 3h cubed. But they all have lots of factors of h. Perfect. I don't need to know exactly what they are, except that they all have at least 2 factors of h. Also, we get to cancel the x to the n. So what we have left up here is n x to the n minus 1 times h plus something x to the n minus 2 h squared plus something else x to the n minus 3 h cubed plus until we get down to h to the n. Everything has an h, right? Yeah? Okay. Let's except no, the first one still has that h.
Oh, okay.
Yep, that's a factor. Yep. So let's factor out the h. So we get x to the n x to the n minus 1 plus something x to the n minus 2 times h to the first plus something else x to the n minus 3 h squared plus, and then we're all the way down here at h to the n minus 1. Right, I just took an h out of each of them. Now, we're going to cancel all these h's, but then when you look at what's left, this doesn't have an h, but everything else does. That's why I don't care what those coefficients are, because we're going to let h go to 0. What do we get if we let h approach 0 now.
And
Mm-hmm. So like what we've just deduced right now is that the derivative with respect to x of x to the n is equal to n times x to the n minus 1. So we're going to go back to our notes in just a minute, but let's suppose let's suppose my function was x to the 7th. What do you think dy dx is going to end up being?
7x to the 6th.
Yeah. We don't have to do the limit. We know what it's going to be for a function that looks like that. So this is sort of or I guess our first big rule of finding derivatives. We're going to spend really the rest of our time learning how we find derivatives of functions in ways that allow us not to have to set up the limit. There's still going to be a bit of work involved. We have to be careful. But yeah, we're moving away from having to do the limits the whole time. And we're going to focus first on just looking at polynomials because that's what will allow us to use that rule that we just learned here. So we have some basic rules. The first is that the derivative of a constant function is 0. That kind of makes sense. It's not changing at all, so its rate of change is 0. Or when you want to think about it in terms of tangent lines, a constant function is itself just a horizontal line. So any tangent line, any line tangent to that function would be just that same line. Yeah.
We're going to have to memorize these, right?
The rules?
Yeah.
Yeah. So there's the derivative of a constant is 0. Just a constant doesn't change. That's why we call it a constant. Right? There's that rule we just derived. We call it the power rule. The constant multiple rule. We can pull out constant factors. It's crucial that it's a constant factor. So I can't pull out like a variable factor, but I can pull out a constant factor. And then we can also split up a derivative over a sum and difference. Like if I'm adding or subtracting terms, I can just find the derivative of each term and then throw them together. There's the derivative of the whole function. We cannot split it up over multiplication or division.
Oh, God.
Where there's a whole section, in fact, it's the next one that we're going to look at on Friday on how we handle multiplication and division of functions. So, all right, let's do some examples. Look how much room I left for each of these to find the derivative.
0.
That's a good sign. We're not setting up limits anymore. If y is equal to 5, what's dy dx?
0.
Yep. If y is equal to x cubed, what's dy dx? Say that again.
3x squared.
3x squared. If y is equal to x,
1.
yeah, it's 1 because x is x to the first. So if you use that power rule, it's 1 times x to the 0. And what's anything to the 0 power? 1. So it's just 1. There's some books, I don't know if this book does, but the other book we used to use would present like a linear function like it's its own special rule. Like the derivative of kx is just equal to k. And that's true, but it's also what you get if you just apply the power rule and know that you've got x to the first power. So.
Didn't you mean to put 1?
Oh, yep. I was just joking. Little humor. I'm going to, there's some of these that I'm going to do in a couple, 2 or 3 steps, that after you do a bunch of these, you're just going to be able to go straight to the derivative, and that's okay. That's the idea, is that we're going to get so good at this that I can look at that and just write down what the derivative is and not really have to worry about it. There's going to be plenty of functions where there's going to be a lot more work to do. So like these polynomials are just going to end up being like cake for us, okay? 3x squared. So that constant multiple rule, the one that says we could pull out a constant factor, the way that sort of manifests itself is that when I find dy dx, I'm just going to pull this factor 3 down, and then what's the derivative of x squared? Yeah, just 2x to the first, or 2x. So then we just get 6x as a result. A lot of the time people will just say, okay, I'm going to bring the 2 down, multiply by the 3, and reduce my power by 1, right, and get directly to 6x, which is fine to do. Here we've got a bunch of terms, but I'm not worried about that because I know I can split up a derivative over addition and subtraction. So when I find dy dx, I've got some constant factors to bring down, so I've got 5 times, what's the derivative of x to the 6? Say that again? 6x to the 5th. And then I just bring down the subtraction, bring down this 2. What's the derivative of x to the 5th? 5x to the 4th. Bring down the plus, bring down this factor of 4. What's the derivative of x squared? 2x. Bring down the minus. What's the derivative of 3? 0. And then I can simplify. So we get 30x to the 5th minus 10x to the 4th plus 8x.
Can I ask why? Is that how you want us to do it? Or is
No.
it okay to-
It's fine to just do it. Like, eventually you're going to, maybe you're there already, but like, you know, the idea is that we can look at a function like this and be able to go right to the derivative. Like, oh, bring the 6 down, times 5, that's 30x to the 5th. Bring the 5 down, times 2, that's 10x to the 4th. 8x, like, and that drops out because that's a constant. There's going to be plenty of functions more complicated. So like the fact that these polynomials should be cake, or will be cake by the time that we're done doing some practice, if they're not already. Like, the idea is that these will become something that's so simple that there really isn't much work to show. And that's okay. In the beginning, you might find it helpful to kind of practice those rules and like what they mean, but you want to do another one? Yeah, you do. We want to find f prime of 1, so well, we're going to start by finding f prime of x, right? So to find f prime of x, get the derivative, plug in 1. So what is f prime of x? 28x to the 6th. Okay. Can you explain how you got 28x to the 6th?
7 times 4 is 28 x. Then you subtract 1 from the 7.
Right, yeah, just knock the power down by 1. Now we can find f prime of 1. Which just gives us 25.